Hello, welcome to another episode of Free Code Session. My name is Jason Bach, and I am going to do one more thing here with this little fun problem that I found in that book that I talked about. This feels like really crappy code. So, the idea I had, and I think I can do this, is to do something like, excuse me. So if we take the number, close that out. Where is the magic one number? One is the longest number. I can't sing. Alright, so the idea is instead of going up is to do the other. So is to basically say I is equal to 9, I greater than 0, I minus minus, or something like that. Okay, and then take this, and what I want to do is not only chop it, so I basically get that, or whatever. Basically, I want to do that, and then get that. Okay, and then what I want to do, well, first I want to not chop it at all. That's what I want to have here. Okay, and then mod that by 9, and that should be equal to 0. Okay, if it's not, stop. Then to do this, mod 8 should be 0, and then we have 9. Okay, keep going. Now we should have, obviously where I'm going with this, mod 7, but now I have 9 and 2. Okay, and just keep going down until I finally get to, what would that be, 38 mod 2. So actually I think this should be greater than 1. That should be equal to 0. And then I should have 9, 2, 7, 4, 5, 6, 1, 8, 3 in there somehow. I don't know how, but I'm going to figure that out. Okay, so somehow do this so I can iterate this, and say if the number that I have is that, then chop that, put it in there, and set the number. I think that's what I want to do. Alright, so we're going to do another benchmark. What are we going to call this? Second attempt. Third attempt. Int. Third attempt. Why don't I even do this? Third attempt. Reverse. Say for var answers equals a new list of ints. Return answer z. So for var I equal to 9, I greater than, what did I say, 1? I think. No. That would never get anywhere now, would it? Okay, so now what I want to do is say, actually I need a for var n is why am I singing the Halo theme? Today is actually the day before the 23rd, and since we're going to be visiting family for a couple days, we're actually going to be doing Christmas tomorrow. So I guess I'm in a festive mood. I don't know. And see all the possible ends that we could have. Okay, now I say if r is equal to math dot divide rem. calculate the quotient of 2 sine theta n I out var remainder. So R is the number. It's not what I wanted to do though. If n mod I is equal to 0, then we can move on. Okay. Need some flag out here too to say should I actually include it. Okay, so people might, by the way, look at this and go, why are you doing a one-liner? It's because I like to be consistent with for each is fors, ifs, all that stuff. That if there is only one, still put the braces around it. I still like to be consistent about that. And if it's a simple thing that I do that. You know, it's not always consistent that way, but anyway. All right, so if that's true, then what do I need to do? I need to somehow grab that bottom number. So if I say 15 mod 10, that's 5, 11 mod 10 is 1. So if I just say, okay, var uniques equals new hash set of ints. Uniques dot add n yet 10. Okay, so if not equals 0, now we should have in here the same number if uniques that, then we didn't find one. And we can break out. But we need to break out and say include equals false and break out. Okay. Because that means we didn't add 1. However, if we did find a 0, we also need to do this. It's probably not quite the most elegant thing in the world. But there we go. Okay. Next time we come through, it will be 8. But it's still the whole number. We actually need to trim it down. Does add tell you if it actually did add? I'm kind of curious. What is the .NET HashSet? Oh, we don't even need to do that. If it's not equal to 0 and or it's equal to 0 or not unique add, then we do this, and that takes care of all that. Okay. Except I'll have to special case when you get to 2, because I don't think that'll work quite the way I want it to. Alright. Well, if I come to, if it was okay, I still have to do this, I think. Because if it wasn't equal to 0, then you don't include it and you get out. Okay. So here now we do is number is equal to number divided by 10. And then we come through, we get to 8, and do the same thing. Now, if we were at 2, if I is equal to 2, that means we did the test, but now we still, so if we're at 2, that would mean that we're at like 12. I'm just going to use the number at the first one there. That would mean we need to so we did 12 mod 2 is 0, unique number 12 to 12 mod 10 would be 2, add. So if it's 2, what we need to do is actually then say our unique is equal to number divided by 10. So if it was 12 divided by 10, we want 1. If it was 21 divided by 10, we want 2. And then we do this. Else. I think this is right. Okay. So it's a little smaller. It does use a hash set. This could probably be cleaned up even a little bit more, but let's see how bad this fails. Doesn't this just show how pessimistic I am? Their attempt. Let's see where this fails. Huh. Again, I thought this would be a lot faster than the other way. And I got the feeling this is not doing what I expected it to do. Let's stop. That's okay. That is all right. Edit. No. God, I can't. It is late. I've learned that the older I get, I just can't code late into the night anymore. It just doesn't work. All right. Let's see what this is doing. Got the answers. We include it. Number is that. So number mod. Well, what's I? I is 9. So that's divided. Okay. Then unique should be 9. It's not equal to 0. And I did add it. So now unique should have 1. Okay. That's... And now number should be... Boom. Goes down. Okay. So now... That says include false continue. Oh, we stay in the loop. I actually want to break out of the whole thing. That was my mistake. Break is right? Maybe break isn't right. Hold on. Oh, that was exciting. All right. Why? I'm totally brain dead. A break should actually... Oh my god. I can't believe that this is like 4... I can't even think. I just got to go through this. Okay. We know the first one's going to work. The second one should not. Yeah, that's what I wanted as a break. Okay. Well, look at that. I found the right answer. It just found, it took forever to get there. That's kind of surprising. Although I do think, wait, now that wasn't there something I said, yeah, if the number, I didn't put that check in here, that's going to get rid of half of them. Too much. So if it doesn't equal 0, then we're going to do all this stuff. That's going to get rid of half of them right off the bat. Wow. This is why you do benchmarks, because this actually surprises me. I thought that this would be a lot faster than the other method. This one I thought was very klutzy, very slow. I thought this would be actually more elegant to do it, and while I came up with the right answer, it definitely does not seem faster. So let's do this. Let's go into release mode, and I'm going to run benchmark, and when it's done, we'll come back and look at the results. Oh, wait. No. To run the benchmark, you have to enable the benchmark. All right, now I'll come back. All right, we're back. Yeah, I was shocked that not only is it slow, but it has that many allocations. That really threw me. So now I got to go back and go, why? The answer shouldn't be it. That's just a list. Is it because it does this hash set all the time? That's just bizarre. That really threw me. Why would this be taking so much memory? The only thing I can think of is the hash set, and that I'm not. I wonder if you also set a capacity on this. What you think the capacity would be is 9. That was just really surprising, and that's the only thing I can think of is the hash set is taking that much. Well, that was a lot quicker. Well, it felt quicker. I mean, but feeling is not the same as feelings are not the same as believing. I don't know. Yeah. Let's do that again, and I will be back. All right, we are back, and better. It's definitely better, and it's not as good as the other one, but it's better than what it was before, and the memory has gone down significantly. It's only 408 bytes, whereas making that that hash set over and over again was just killing me. You're killing me, Smalls. You're killing me. So that's interesting. It's interesting that using the hash set, was adding that much more memory, and that this is actually twice as slow. That is really surprising to some degree. I guess maybe the overhead of doing the add, because really what I'm doing up here is I've got, distinct numbers that I'm only looking through, and as soon as that doesn't work, it pops out, and that's it. Whereas if I wanted to do this here, I'd actually have to somehow keep, not a literal array, I don't think. Though it'd be interesting if I said make an array 0. I'm sorry, I have 9. And then I did a comparison on the array from all the values up to where you were. Would that actually be faster? I don't think that should take that long to do. Okay, and this will be the last thing I do. This will be the last one I'm doing. Get answers. Fourth attempt. With unique array. So here we're going to say new int of 9. Okay. And now here, I wonder if I can do this. I think that's legal. Yeah. It's going to look weird. Two, 3, 4, 5, 6, 7, 8. Okay. So now what I need to do is say else. We need to now actually look through so if we're at 9, we do uniques at I minus 1 is equal to unique for var k is equal to what I want to do is look at the number I just added and compare it to all the previous ones. Because if before that, those two should have been compared, so those should all compare, right? So I want to say for k, I minus 1, k no, k minus I want to start looking. I want to, if I'm at 9, I don't have to. If I'm at 8, I need to do 7 and 8. If I'm at 7, I need to do 6 to 7 and 6 to 8. Because 7 would have already compared to that. So I need to take all the numbers that you got. Well, I technically don't have to do it in this order. Right, I don't have to. I don't have to do it in this order. So, but I have to compare what I put in to all the previous ones. If I don't know if the mod would actually matter that much in this case. It's just confusing me to do this, so alright, I think that's what I want. So now I gotta do this crap logic again. Feels a little dirty. I'm not sure this is what I want. If 9, well then it's 9. But that's not actually, it's not actually true. Because if I did this, it'd be uniques at 8. It'd be the 8th, which is the 9th, and that's not what I want. You have to do -1 on both of these, on the indices. Because if I is 2 here, two is the special case. Well, wait a minute. Oh, that's right. 2 is the special case because you fall through it, so it's actually 1. If that makes sense. This is kind of a special case. Because 2 up here would be 1, and now I'm actually 2. What I'm actually trying to do is the 1, which is the 0th. So here I'm saying k is 1 less than 9. So now I'm always trying to compare this to the kth. right? Because I'm going 0, then 1, 2, 3, 4, 5, 6, 7, 8, and that should be enough. I think this is right. How many times have I said that before? I could see the 8. So K would be 9 to 9, so just fall through. It wouldn't do this because you only have 1 in there. Second one comes through as 8. 8 minus 1 is the 7th. So K is 7 to 9. And what I really should do is say if K that's what I'm trying to do. Is I'm saying if I'm at 8, then that's 7. Is that equal to 8? And then I fall through. Now if this is 7, that's the 6th one. 7, 8, 9. So it's 6 and then 7. Right. 7, 8, so it should suit 7. No, wait a minute. No. That's right. Because if I'm 7, I'm saying the 6th up to well, that's 7. Then I don't say that, right? Because if I had 7, then that becomes K would be 7 and 8. And so what I want is to look at the 6th one to look at the 7th, and the 6th one to look at the 8th. So 7, 8, right? Because K is always a if it was 7, it's always going to be 6 compared to 7, 6 compared to 8. Let's say I is 6. So if the I is 6, K is going to go to 6, 7, 8. 6, 7, 8. 6 minus 1 is 5 to 6, 5 to 7, 5 to 8. Okay, that's right. I think that's right. And in the case here, you're going to just go all the way from K1 to K8, comparing it to the 0th one. Okay, let's see what this gives. I'm going way over my usual time, but hey, it's a Christmas special, right? Let's see how this fails. Gotta get some index out of bounds thing, right? Well, it does the right thing. Okay, so we're gonna do one more time. And I will be back when this is done. Alright, so this is the last time. It did get better. It's almost comparable to the fastest one. Not quite there, but it's, and even these two are almost the same. This one's slightly slower, consumes a little bit more memory, not as much as when you use a HashSet. I guess some thoughts on this is mainly that sometimes, I hate to say this, but sometimes when you write code that looks like this, which is quite crappy to be honest, it feels faster, and I hate saying that because I know my brain is still going to be looking at this later or thinking about this and going, how could I do this better? What could I do to make this better? At this point, I'm not really sure what I could do to, I just, not to say that I can't, my brain is fried. I can't think of any more ways to make this any faster than what it is. So sometimes you need to do special things. Like the hash set here makes it easier to code, but as you saw with the memory results, using a hash set is made it that much slower, and consumed what, 2.5 times more memory. Which you can say, I've got gigabytes of memory on my machine. Why should I care about this? And yeah, arguably, whatever. But if this was a hot path in your code, or this was something that you could say, hey, why is this taking so long? Well, you could trim it down to this by using an array. Now, you can always say, I could even go this far and completely get, I'd say of all the approaches, this one is almost the easiest one to reason about. Okay. And even this, why do I make the hash set and clear it? Well, if you don't, look at how much memory was being consumed. That was ridiculous. It's just insane. That you just keep creating a hash set over and over and over and over and over again. Whereas this one, you're just doing one, and I guess clear is better. But that to me was the one that I think is the easiest to read. This one's, it at first glance looks hard. As you start going through it, you can go, okay, I kind of get what this is doing. But it's still not the cleanest, so as we saw, this one is literally the worst. I wouldn't even put that in a benchmark because it's just so awful. Though I think in some ways, if you actually look at this, it almost reads the best, if you can even think of it that way, because you can go, oh, okay, well, you're times that 10 and then adding 1, and divide by 3 is this one and adding them, and and I could almost say, you could take this and then optimize it to only do the next one if it's 0, blah blah blah, But this one, I think, in some ways also reads pretty well, but it performs absolutely abysmally. It's really does. It just, I guess I could let this run overnight and see if it melts my machine, but that would be bad. Okay, so this one's definitely not one that you want to use. Okay, so this has just been fun. This has been a fun little excursion with that thing I saw in the book, and I think it's been fun just to kind of play with this and say, how can you make this faster? I know in Roslyn, there's some cases where they'll use very specialized collections and very specialized code. I know I've seen in a couple of other articles where sometimes code is written in such an obscure way because you're trying to get so much not so much, but you're trying to eke out that last bit of performance. And to do that, you're doing very, very, very specialized things in your code that arguably you shouldn't, but if you can prove through performance, benchmarking, and all this other stuff that it is going to be faster and better overall, and that is something that you can quantify as a hot path and something that you could potentially make better, and it's worth it, then you might have to do those kinds of things. This would definitely not be a good one. This is one where you'd almost say, comment it and show that, well, this is what I'm doing. But then if you did that, you could say, well, this don't lie. It's arguably always, I think, come up with the fastest number every time I've done this. The memory consumption is, about the same, though the first real attempt is, it's the same like this. This one was just, it's a smaller upper bound. That's why it's slightly better. Same thing with, with this one, or any of these. The point is that the fastest way and the one that consumes the least amount of memory is probably the one that's the hardest to read. Yet it performs the best. So that, I think, says sometimes, not all. I mean, you don't want to do something like this before. When I was writing this code, I was just like gagging a little because this is just not easy to comprehend at first glance. But there you go. I mean, well, what can you say? This one just seems to trump all of them. So gives you the best hand. So you gotta take what you get. So it was fun. I enjoy problems like these, and they're always and benchmark.net just makes this so simple to throw these into a test benchmark class and say, go just go benchmark them for me and give me a lot of good meaningful results. So Next episode, I have to get back to the whenever compiler, dub sharp, actually start compiling things, actually start creating assemblies, and at least get to some headway. At least if I can, if I can get into the dub sharp and actually say like I have, this. Do you need a colon at the end? I don't think so. And then if I say, or whatever it is. I mean, just something like this. I think that actually would suck because you never take the one lines away. But you get the point. Is doing something like this where I can actually parse it and get a meaningful program out of it, and start doing other things. Like I gotta get to it because that presentation's coming up and I need at least something to demonstrate. So that's all I'm going to do for this episode. Next time we'll start doing some compilations, some parsing. So thanks all y'all for watching. Leave your comments and questions below. See you in the next episode.